Hello friends, this is Yusuf here. Welcome to part 9 of our crash course RPGLE. So in this video we're going to learn about subroutines and subprocedures. Okay, so until now we are like dealing with a plain program which like executes from top to bottom. So we have not talked about subroutines or subprocedures. Okay, so but when we do actual coding, right, so there will be a large number of codings, like 1,000 lines of code, more than that. So on that time, for the readability and then the organizing code, right, subroutines or subprocedures are very much useful. And also in between these two, subprocedures has a lot of features. Maybe we'll see one by one in our future video, but today we'll just get into the introduction of what is subroutines and subprocedures. Okay, so basically, right, subroutines are a small piece of code which is actually a particular logic which you can group together and then name it under a subroutine so that you can call it from wherever you want inside the same program. Okay, and basically subroutines are used for grouping logic, okay, and also for the readability and then organizing the code. Okay, so it looks clean. But on the other hand, the sub procedure that has a lot of advantages. Okay, and even the basic concept of ILE can be achieved through sub procedures. Yeah. Okay, so sub procedure on the other hand, right, it acts like a sub program. Okay, which means it has its own local variables. It can accept parameters and then return values. Okay, and then we can use a lot of ILE features on top of the sub procedures. Okay, and it usually used for modularizing code. Okay, when I say modularizing code, right, so you may have some certain functionality which could be used in many programs. Okay, so for that kind of things we can make a sub procedure so that need not to be written as and when it's required. We can just call it. Okay, that's called modularization. And the another key thing is the sub procedures can be exported outside the program so that the other programs can use the sub procedures of another program. Okay, so maybe we'll see these things in examples going forward. With this introduction, let's get started. So let me go to the IBM. Okay, so here we have a plain old normal boilerplate of our RPGLE code. So what I'm going to do, actually, I'm going to declare a variable called a quickly with 3s0, and then I'm going to say rp2 and then say b and then c. So we have just declared two variables, and then here I'm going to say display enter number 1 space then a. So you all know this will get the value into the a, and then I'm repeating it for b. So we are getting just two numbers from the user, and then I'm simply saying c is equal to a plus b and then display c. So there is nothing to do with this code. It's a plain normal RPGLE code which just displays summation of two numbers. But now we all know it will work, right? So I'm not going to execute it. But what I'm going to do, I'm going to make this calculation into a subroutine. Okay, so subroutine is actually a piece of code which can be there anywhere in the program. So here I'm going to again say free and free. So this will become a section, right? Okay, in this section I'm going to say BEGSR, okay, begin subroutine space subroutine name. So I'm going to say add SR. Okay, you can name whatever you want, and then end SR. So this BEGSR and end SR is actually a beginning and ending of subroutine, and inside we can have the code whatever you want. So what I'm going to do, I'm going to move this code to here. Okay, and then give some indentation. Okay, so what we have done here, so we have moved a piece of code from the main program to the subroutines. Okay, so we need a way to call this subroutine. So what I'm going to say, after we get the two value, I'm going to say EXSR. Okay, execute subroutine add SR. So what this will do, this will call this particular subroutine. Okay, so we can call this add EXSR as many times you want, and whenever we do that, this particular piece of code will be executing. Okay, so this is a basic syntax of subroutine. Okay, let's see. Hopefully we shouldn't get any errors. Let me compile. Oops, test SR. Okay, call. So it asks for value. I give 10. Second value may give 5, and you can see the result 15 is displayed. So that's pretty much with the subroutine. What else I can say about subroutines? Okay, in subroutines we have another keyword that might be useful in sometimes called leave SR. Okay, as you know, leave SR is for leaving the subroutines as and when we want. So just I'm saying display inside add SR, and then copy this and then paste it like okay. Before that I can say something like leave SR, it should be a semicolon. Okay, so what we have done here actually, okay, so we have a display command here and then calculation and then leave SR and then display again after leave SR, just to differentiate stuff. Okay, let me quickly comment this one and then show what happens. So nothing fancy, we'll just display two more display command inside the subroutines. So if I compile and then call, then give some value like 5 and then 5, you can see first inside add SR is displayed and then the C is equal to A plus B will execute, and then after leave SR is displayed and then the value 10 is displayed. Okay, but if I uncomment this portion, okay, then what is expected is actually the whatever code which is there on below will not be executed. Okay, leave SR will go back to the calling statement itself. So just test that out. Call, I give maybe 6. So the first display is executed and then calculation will happen and then immediately see the value is displayed. So the second display command is not executed because of the leave SR. So that's pretty much the introduction of subroutines. Okay, nothing more, nothing less. But let's go to the interesting topic of sub procedure. Okay, so now what I'm going to do, I'm just going to make this subroutine into a sub procedure. Okay, so let's convert this. So before converting, I need to add one statement here. Oh, sorry. So let me do file test sr1. So I'm just duplicating this program to test sr1, and then inside I'm going to say in the header specification dft act grp no. Okay, so this statement enables this program to become an ILE program. Okay, so until now whatever we have seen is actually a plain RPG program. We have not used ILE concept. Now we are going to use it. So in general, non-ILE programs, okay, or general programs, so called OPM programs, will run under default activation group. Okay, so if our program is ILE program, then our program should not run under default activation group. That's why we say default activation group is *no. Okay, fine. As of now, leave that portion as of now. Okay, so let's see what we need to do, what changes we need to do to convert the subroutine into a sub procedure. So first of all, here, okay, after everything, let me give a star just to give some spacing. Okay, therefore I'm going to declare a procedure. Okay, and then I'm going to name this procedure, maybe say add, enter. Okay, this is a one line we need to add on top. It's called a declaration of the procedure itself. So this procedure, we have said in the beginning of the program that we are going to have a procedure called add. So how do we declare it? So in this section our coding starts, right? So here let me give some space. Okay, before we start the code, I'm going to say a P specification. Okay, first time we are going to see a specification called P. Take F4, it will ask you a procedure name. I'm going to say add and then begin and end. So I'm going to say B, it's the beginning of the procedure. Okay, and then as you expect, I'll copy this line at the end, I'll paste it and then say it's a E. So a P specification of begin and end is actually a procedure start and end. Okay, so inside whatever we have it in free is code or a calculation specification as of now, and we don't need this BGSR and then endSR because we don't have a subroutines inside the sub procedure as of now. Okay, and then we don't want this leave SR as well. Fine. So now what we said there is a procedure called add and it's beginning and ending, and this is the coding for that particular procedure. Fine. And we also said that procedure we declare on the top just to tell the compiler that there is a procedure coming called add, and we cannot use EXSR, so I'm going to use call P. Okay, and when I use call P, I need to use like this. Okay, it's calling procedure. So that's it. So we just converted the subroutines into sub procedure. So if I compile and run, I should not face any issues and it should produce the same result. Let's see. So it's compiled. It's asking the two numbers. I'm saying 6 and then 6, and inside ADDSR is displayed, and then after leave SR is displayed because both are inside the sub procedure, and then value 12 is displayed. Cool. So we didn't face any issues, and we just converted a subroutine into sub procedure. Okay, now you can ask me what is the big difference we had, or what value we got from this subroutine to sub procedure. As of now, nothing, because this is not a good way of sub procedure. Okay, so let's add some features of it. So currently, right, when someone looking into the code, they will see, okay, call p add. So we are calling a procedure called add, but we don't know what the add is doing. Okay, but basically the add is calculating the a plus b value. So what I'm going to do, I'm going to create parameters to pass in. Okay, I'm going to pass in the parameters a and b. So there comes the interesting portion. So first of all, what I'm going to do here, in this p specification, I'm going to add it. Sorry, let me go to edit mode. Okay, so here after the p, I'm going to say d, take f4, add pr. Okay, so whatever we gave on top, right, so I'll repeat as a pr, and then we need to say a pi. Okay, pi is called procedure interface. Okay, under the pi we have to define our own variables. So here I'm going to say take a for number 1, and I'm not giving s here because it's not a standalone variable, it belongs to pi. So here let me say 3 yes 0. Okay, and then I'm going to say number 2, that is also 3 0. So now we said this procedure is having a procedure interface of 2 variables, which means it can accept 2 variables as input, as a parameter. Okay, so to match this prototype, we also need to change this. How we need to change? We need to add 2 more d, and then we have to take f4. Here this name of the variables is optional because we just need to match the prototype. So here 3 yes 0. Okay, and then here also 3 yes 0. So now you see what the difference we made. We just added 2 parameters for this procedure as 3 as 0 basically, and inside this pr we had a pi section coming in, and then it accepts 2 variables, number 1 and number 2. Now I don't want this a and b, I can say number 1 plus number 2. Okay, but still I'm using c because c is actually a global variable because we have declared at the top. So all these variables are visible into the subroutine as of now. So I'm just going to stick with the C, and I don't want this after this extra line of code. Anyway, so I'm just using this number 1, number 2 here. Okay, what else we need to do? So what else we need to do? So here it's not a single call anymore, it has parameters. So I'm going to say a colon b. So I'm passing a and b as a parameter. Okay, so that's it for creating the sub procedure with parameters. Let's see if it works. File 14, so it's compiled. So I'm going to calling, I'm going to say 4, and then it displays the inside ADSR, and then it is calculating the value, and then it's put into the variable C, and then we are displaying the C. It works fine. Okay, cool. So now it gives a little bit more readability. We can see like from here, add a b. So we are going to add a and b, so it's kind of clear. But to make more advantage of sub procedure, I'm going to do another thing. Okay, nothing but, so I am here going to have another variable called sum. Okay, and here I'm going to say it's yes, and then maybe 4 yes 0. So now you see we have declared with the standalone indicator, which means this variable is actually a local variable, belongs to the sub procedure alone. So this variable will not be visible to the other procedures in the same program. Okay, and since we have s here, which means these two will be the as part of pi, but this third variable is not as part of pi. Okay, it's a variable which this sub procedure can use basically. And now instead of c, I can say something like sum is equal to a plus num1 plus num2, and then I can say return sum. Sorry. Okay, so we're gonna return the sum. So when we are returning some value, we need to put that also inside the template or declaration. Okay, so here we say we accept these 2 values in the PA, but if we are returning something, that variable's declaration should be data type should be available in this place. Okay, so 4 yes 0. so in the PI line, okay, in the PI line, okay. And then we need to match this prototype on the top also. So here we have declared add, we say it's have two parameters, but we also need to say here 4s0, okay. Now this matches with the prototype. Fine. So now we added the return value. Since we added the return value, we don't need call p anymore, okay. I can say c is equals to a plus b, but now c is actually a return variable in our case, and the return variable here is actually a 4s0. So I'm going to change this c to 4s0 just to make things matching. So let's see read the code now, okay. C is equal to add of a and b. Now it's clear, like it gives more clearer picture on what we are trying to do, okay. So let's see whether are we getting the same result. Let's compile, call. So I'm 7 7 and it displayed the same 14, so no issues. So but what we have done here, we have like took the advantage of sub procedures, and then we made the program look more clearer and stuff. But still, let's go another level. So what else we can do with sub procedure? What else we can do? Okay, look, it's a trick, okay. Now what is happening actually when we call this add procedure with the variables a and b, this a and b value is coming to these variables num1 and num2 basically, right? That's why we are able to access this value. But let's see what happens if I change the value of number 1 here to 5, okay. And after displaying the result c, I'm also going to display the variable a, okay, because I cannot access the number 1 because it's inside the procedure, but I can access the variable a. So we passed a into number 1 and we are changing the number 1 value, and then I'm displaying the a again. Let's see what happens, okay. So file, compile. So see, I'm giving the value of a as 10, also value of b as 10. So it goes inside subroutine, and then it displays the value 20 as the calculation, which is correct. But when I'm trying to print the value of a, it displays 5, but we gave 10. So what happens here? Actually nothing but the change of num1 is reflecting back to a. That is because what happens technically when we pass variable a and b, right, the address of variable a and the address of variable b will be passed to these two variables number 1 and number 2, okay. That's why we are able to access the value of number 1, number 2, okay. And then when we change something on number 1, what we are doing actually, we are changing the value of this address to 5, but this address is already belongs to the variable a. That's why it is reflecting value variable a. But ideally we do not want to do this, right, because these variables a and b are meant to be input variable, not the output variable, okay. So how do we do this? So for this there is an ILE concept, okay. Nothing but when we declare these two parameters, right, on the procedure, what we need to do on the number 1 and number 2, take a 4 and then say the keyword const, okay. So when you say a two variable as const, technically you cannot change the value inside the procedure. Now we have declared as const, then we also need to give it here const, okay. Now it's matching with the procedure declaration. Fine. So now we have given here as const, but we are trying to change the value of number 1. Let's see what the compiler says, okay. File 14, so we got error, okay. And if you go and then see, you can see, right, the operation modifies the field, but the field cannot be modified because we are trying to change the value which we defined as const. So now this line is no longer valid, so I'll delete this. Yeah, that's it. So now you understood the purpose of const, right? But due to this particular const, we are getting another advantage, okay. What is that advantage? Is nothing but, okay, now let's see, we have the two numbers coming in, and then we are just calculating the addition and displaying it, and then I'm going to say copy paste, okay, and then maybe display C again, okay, for the result. And here I'm going to say maybe 33, okay, and then 10, okay. Now what we are doing, we are passing the value directly in onto the procedure call. Okay, just because we have declared that as a constant, the compiler knows, or the system knows that okay, whatever we pass, that's not going to change. So for this purpose, even if you just pass values, it will take care of executing it, okay, without any problem. Let's see if this works. File 14, good, compiling, no issues, call. So it's first time it's asking values. I'm going to say 10 and then 10. It goes inside the program and then calculates the value and displays 20. Now it's calling the program procedure again, because we have given call p of 33 and 10, and it calculates the value 43. Okay, so how cool is this? So now you understand, right? This is the subroutines and subprocedure basic concept. And with subroutines we cannot do all these stuffs whatever we have seen actually. Okay, with subprocedures these stuffs are possible. So with this base understanding, we'll go next and then we'll create a lot of things. So since we talked about sub procedure, okay, let me give this another example. How do we call another program inside this program? Okay, till now we are calling within the same program, right? So say for example, we have this test SR, right? Okay, the test SR program just takes two values and then calculates the addition. Okay, so I'm going to create another program called test SR, maybe 2, default activation group, no, and then free. I think it may be a little bit longer video, but still I think these are important concepts, so I don't mind. Okay, so we're gonna call test SR. Okay, so here I'll say TSR and I'll say it's a PR, but here I'll say EXTPGM. It's an external program with the name of TESTSR. So this is the syntax for calling a program, okay, inside a free format. Okay, so here once we have done this, we can just call call p okay, test SR. So this will work. Okay, so let's see. So we're gonna file this one and then compile it, call. Now you see test SR is called. So if we give 5 then inside ADSR 10 display. Okay, and another advantage is actually when you prototype something, right, this variable is customizable. You can say like add num. Okay, it's still possible, and here you can say add num. Okay, it will still work. And the usage of call p is actually an optional. It will still work with add num, but just for the readability, people will use call p as well. Okay, now file and then compile, call. So the first time it's calling, we give a number maybe 6, it displays in CDDR and then 12, and then it's calling the second time, okay, without the call p. Okay, maybe I can give 4, 8. Okay, so that's it for how much time it took. 23 minutes. Okay, good. So that's it for this video. I hope you got a brief idea about what is subroutines and then subprocedures. Nice. Okay, anyway, so we'll see more things in coming days as usual, because we have just passed halfway through our tutorial. We have just completed the 9 portion, but we have our 18 portion tutorial. So what is coming next? We can go here and check. What is this? Okay, so we completed this portion now. Maybe yeah, so next is all interesting topics coming in. Okay, built-in functions, error handling, PF, LF. Yeah, so I'm excited to make the video anyway. Okay, thanks for watching. So that's it for this video. Hope this helps, and if you have any doubts and comments, leave me in the comment section. Okay, see you in the next time with different concept. Not different concept, maybe the part 10 built-in functions. Okay, so until then, see you from Yusuf. Bye bye.